Why does the most feared substance on Earth needs to be processed before it becomes truly dangerous? We're told uranium's the key to apocalyptic power, both in bombs and reactors. But raw uranium ore, the yellow cake powder you might see in photos, is virtually harmless. It can't blow up a city, it can't even power a light bulb. To become the stuff of both energy and nightmares, it must undergo a monumental industrial-scale transformation called enrichment. This isn't a minor step, it's the single greatest technical and geopolitical barrier on the planet. The question isn't just why it's enriched, but what this brutal, necessary process reveals about the razor-thin line between a power plant and a weapon. Forget the chemistry, understand the physics. Natural uranium is almost entirely two isotopes, uranium-238, U-238, and uranium-235, U-235. They're identical chemically. The only difference is 3 neutrons in the nucleus. But that difference is everything. Only U-235 is fissile. Its atomic nucleus is unstable in a specific way. When struck by a free neutron, it splits violently, releases immense energy, and throws off more neutrons to split more atoms, a chain reaction. U-238 is stubborn. It just absorbs neutrons or fizzles out. Here's the problem. In natural uranium, for every 1 atom of the useful U-235, there are 99 atoms of the useless U-238. It's a 1% solution. A chain reaction in this mix is impossible. The U-238 parasites soak up all the stray neutrons and stop the process dead. To get a sustainable reaction, you must increase the concentration of U-235. You must separate isotopes that are chemically identical, differing in mass by less than 1%. It is, as one physicist put it, like trying to separate red sand from slightly redder sand. This is enrichment. The dominant method is gas centrifuge. First, uranium is converted into a gas, uranium hexafluoride. This gas is pumped into thousands of spinning centrifuges, tall, thin cylinders rotating at supersonic speeds. The heavier U-238 gas molecules are flung slightly more to the cylinder's wall, while the slightly lighter U-235 gas collects a bit more towards the centre. A small concentration gradient is created. The slightly enriched stream from one centrifuge is fed to the next and the next in a cascade. The depleted stream, now with even less U-235, is cycled back. It's a process of infinitesimal increments, repeated across tens of thousands of machines, running for months.
The end product is defined by its enrichment level, the percentage of U-235. Reactor-grade uranium enriched to about 35% U-235. This is the sweet spot for a controlled, slow-burn chain reaction in a power plant. The 95% U-238 still soaks up neutrons, which is why you need a moderator, like water, to slow neutrons down so the U-235 can catch them. Weapons-grade uranium enriched to 90% U-235 or higher. This is highly enriched uranium, HEU. With almost all the neutron-absorbing U-238 removed, the chain reaction is fast, uncontrollable and explosive. This is what powers the core of a fission NOM. The machinery is the same, the process is the same, only the duration and the number of cascades differ. Getting from natural uranium to 5% takes about 70% of the total effort required to get to 90%. The final sprint to weapons grade is technically easier than the initial marathon to reactor grade. 3. The 80% reveal. Here is the terrifying truth that the enrichment process lays bare. The primary function of a nuclear reactor is not to create energy, it is to create plutonium. Every commercial power reactor, every one producing electricity right now, is fundamentally a breeder reactor for a weapons material it was never designed to produce. Remember that 95% U-238 in your reactor fuel? It's not just sitting there. When U-238 absorbs a stray neutron from the ongoing reactor chain reaction, it doesn't fission, it transforms. Through a series of decays, it becomes plutonium-239. Plutonium-239 is even more reliably fissile than U-235 and is easier to chemically separate from spent fuel than isotopes are to physically separate from each other. This is the ultimate paradigm shift. Enrichment to 5% for a peaceful reactor doesn't just create a power source, it creates an environment where the majority constituent of the fuel, the useless U-238 you worked so hard to separate from, is transmuted into the most efficient bomb material known to man. The entire multi-billion-dollar enrichment industrial complex, justified for civilian energy, exists within a hair's breadth of weapons capability because the very reactor it feeds is a perpetual factory for a different, superior weapon core. The line was never between reactor-grade and weapons-grade uranium. The line is between any nuclear technology and the plutonium it inevitably physically manufactures. 4. The outro. So uranium is enriched to start a chain reaction, but that reaction's most consequential product isn't megawatts, it's the element that renders the agonizing enrichment process almost obsolete.
The pursuit of atomic energy and the capacity for atomic violence are just related. They are the same process, separated only by intent and a short chemical procedure.